Hello students, this is Dr. Asif, working as Associate Professor and Head in the Department of Mathematics in Vijaya Vittala Institute of Technology, which comes in Hennur Bagalur Road, Bangalore. Let us discuss today's topic, partial differentiation. Let us take another problem on Jacobians. Here we have x as a function of u and v, y also as a function of u and v. That is, x depends on u as well as v, and y depends on u and v. Now we need to prove Jacobian of x and y with respect to u and v is equal to this. Let us find the Jacobian now. Given x is equal to a cos hyperbolic u into cos v, y is equal to a sin hyperbolic u into sin v. The given Jacobian, the required Jacobian of x comma y with respect to u and v can be written as this. Here we require dou x by dou u, dou x by dou v first, and then dou y by dou u, dou y by dou v. Then let us find all these derivatives one by one. When we differentiate x with respect to u, when we differentiate this with respect to u, a and cos v will be taken as constant, and we differentiate cos hyperbolic u. Let us differentiate now. Yes, we have taken a and cos v as it is. Differentiation of cos hu is sin hu. Observe here, differentiation of cos u, if you have without hyperbolic, then it will be minus sin u. But in the case of hyperbolic functions, here cos hyperbolic differentiation will be just sin hyperbolic u without minus. Now let us differentiate dou x by dou v. That is, we have to differentiate x with respect to v. We have to treat a and cos hyperbolic u as constants now. Yes, we have written a cos hyperbolic u as it is, and differentiation of cos v is minus sin v, which we have written here. Now let us differentiate y with respect to u partially now. Since we are differentiating with respect to u partially, we need to take a and sin v as constants now. Let us differentiate now here in this place. We have taken a as well as sin v as it is. Differentiation of sin hu is cos hu. Now we will differentiate y with respect to v partially. When we differentiate y with respect to v partially, a into sin hu will be taken as constant. Yes, we have taken a into sin hu as constant. Differentiation of sin v is cos v. So we have evaluated all the partial derivatives required in the determinant. Now it's the time to evaluate this determinant. Let us cross multiply in this way, then minus of in this way. We have multiplied in this way these two terms and we have written here, you can see. Then we write minus. This minus is from the procedure of evaluation of a determinant. Now we multiply in this way and we write here inside the bracket because of one more minus sign here. Yes, we have written here and here we have taken the product. In the next step, this minus and this minus gets to plus and we multiply these two terms and these two terms. I have taken the same step from the previous slide and we multiply now. A into A gives A square, sin HU into sin HU gives sin hyperbolic square U, and cos V into cos V gives cos square V. We have multiplied these two to get this. Now let us multiply this with this. First thing is minus into minus, it will be plus. Then A into A square, cos HU into cos HU, cos H square U, sin V into sin V, sin square V. Here we can observe A square is common first. Let us take A square outside as we have written here. What remains inside is this. Here we have multiplied and divided by 2. We have multiplied and divided by 2 to bring some standard identities. We have applied this step here. We will take this 2 along with cos square V and we write like this, and this 2 will be multiplied again with sin square V to write like this. Because we have identities for 2 cos square V and 2 sin square V, 2 cos square V can be written as 1 plus cos 2V and 2 sin square V can be written as 1 minus cos 2V. Let us replace these in these places. Therefore, we have replaced in this place 1 plus cos 2V and in this place 1 minus cos 2V. I have taken the same step from the previous slide. I have multiplied the sin h square u with this 1 to get here. Then multiplication of sin h square u with cos 2V to get this step. Similarly, we will multiply cos h square u with this 1 and with this to get these two terms. Now let us assemble the terms. Here we have assembled cos h square u and sin h square u to write here. Now we will assemble these two terms by taking minus cos 2v as common from these two terms. When you take minus cos 2v outside, this minus becomes plus here, plus cos h square u, and this plus becomes minus here because we have taken minus outside. What remains is sin h square u. Again we have identities for this term and this term. The identity says the value of cos h square u minus sin h square u will be equal to 1, and the value of cos h square u plus sin h square u will be equal to cos h 2u. You need to memorize these two identities. In the case of hyperbolic functions, these two identities hold true. Let us replace these identities in the above equation. I have written a square by 2 as it is. This has been replaced as cos h 2u minus cos 2v as it is, and we have replaced in this place 1, which is not shown here.